Assalamualaikum and hi everyone. My name is Nur Atiyah Natasha binti Abdul Razak from class A4AS120120. My student ID is 2023451158. And today, I would like to talk about the periodic table of elements. These are the 5 groups of elements that I will be focusing for today. The first one is group 18, the second one is group 1. The third one is group 17, the fourth one is period 3, and last but not least, the transition metals. As you can see here, I already labeled out all the topics that I will be focusing and talk about for today. First and foremost is group 18. Group 18 consists of helium, neon, argon, krypton, xenon, radon, and organesson. Elements in this group are known as noble gas or inert gas. Noble gas are chemically unreactive due to the valence shell that are fully filled with electrons. These atoms in group 18 exist as monoatoms. Helium atomic radius is 0.050 nanometers. Melting point is negative 270 degrees Celsius, while the boiling point is negative 269 degrees Celsius. The density is 1.7 times 10 power of negative 4 gram per centimeter cubed. Neon atomic radius is 0.070 nanometers. The melting point is negative 248 degrees Celsius. The boiling point is negative 246 degrees Celsius. Density is 8.0 times 10 power of negative 4 gram per centimeter cubed. Argon atomic radius is 0.094 nanometers. Melting point is negative 189 degrees Celsius. The boiling point is negative 186 degrees Celsius, while the density is 1.7 times 10 power of negative 3 gram cubic centimeters. Krypton atomic radius is 0.109 nanometers. Melting point is negative 156 degrees Celsius. Boiling point is negative 152 degrees Celsius, while the density is 3.5 times 10 power of negative 3. Xenon atomic radius is 0.130. Melting point is negative 122 degrees Celsius. Boiling point is negative 108 degrees Celsius. The density is 5.5 times 10 power of negative 3. Last but not least is radon. Radon melting point is negative 71 degrees Celsius, while the boiling point is negative 62 degrees Celsius. As you can observe from the table before, going down the group, the size of atomic size increased due to the increase in the number of electrons and electron-filled shells. Boiling and melting point also increased going down the group. As a result of increasing atomic size, the attraction force between the atoms also increase. When the force becomes stronger, more heat energy is required to overcome this force. Group 18 elements uses in our life. Helium is used to fill weather balloons and oxygen tanks of divers. Neon is used to advertise board lights. Argon is used to fill in electric bulbs and provide inert atmosphere for welding in high temperature. Krypton is used as flashlight of camera and lasers for eye retina. Xenon is used as lighthouse lamps and in anesthesia. And last is radon is used to treat cancer. Moving on to the second topic is group 1. Group 1 consists of lithium, sodium, potassium, rubidium, cesium, and francium. Lithium is used in battery production. Sodium is used in sodium vapor lamps. Potassium is used as fertilizer. Lithium atomic radius is 0.133 nanometers. Melting point is 186 degrees Celsius, while the boiling point is 1342 degrees Celsius. Sodium atomic radius is 0.186 nanometers. Melting point is 98 degrees Celsius. Boiling point is 880 degrees Celsius. The last one, potassium. atomic radius is 0.203, melting point is 64 degrees Celsius, while the boiling point is 760 degrees Celsius. Elements in group 1 have low melting and boiling points if you compare it to the other metals from another group. When atomic size increases, the attraction between the atoms and the nucleus weakens. As a result, less heat energy is required to overcome the forces between the metal atoms. Elements in group 1 have only one electron in valence shell. In a chemical reaction, these atoms will donate one electron and form an ion with +1 charge. Reactivity of this group increases when going down because of the tendency of an atom to donate its valence electrons. The numbers of shells filled with electrons increase when going down, that will make the atomic size bigger. Because of the position of valence electrons is placed further away than nucleus, the attraction force weakens. That leads to electrons are more easily donated. Moving on to the next topic is group 17. Group 17 consists of fluorine, chlorine, bromine, iodine, astatine, and tennessine. Elements in this group are known as halogens and exist as diatomic molecules. The atoms in group 17 exist as 3 atoms. Chlorine is used in bleach. Bromine is used in fire extinguisher. Iodine is used in disinfectant. Chlorine physical state is gas. The melting point is -101 degrees Celsius. The boiling point is -34 degrees Celsius, while the density is 0.003 gram per cubic centimeters. Bromine physical state is liquid. The melting point is -7. The boiling point is 59 degrees Celsius. The density is 3.119 gram per cubic centimeters. Iodine physical state is solid. The melting point is 114 degrees Celsius. The boiling point is 184 degrees Celsius. And the density is 4.950 gram per cubic centimeters. Going down the group, the molecular size will increase, that causes the attraction force became stronger. Melting point and boiling point of halogens increase because more energy is required. Density of elements increase with the increase in mass when going down the group. Elements in group 17 have 7 electrons in their valence shell. In a chemical reaction, these atoms will receive 1 electron and form an ions with -1 charge. Reactivity of this group increases when going up. Increase in atomic size will cause the valence shell to be further from nucleus. This will cause the nuclear attraction force to an electron become weaker. Thus, the difficulty in attracting electrons to fill the valence shell increase. The fourth topic, period 3. Period 3 consists of sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Sulfur are used as fungicides. Phosphorus are used in a substance in fireworks. Aluminium is used as a substance in cans. Magnesium is used as substance in lighter. Natrium atomic radius is 0.186 nanometer. The electronegativity of natrium is 0.9. Magnesium atomic radius is 0.160 and its electronegativity is 1.2. Aluminium 0.143 nanometers as their atomic radius and the electronegativity is 1.5. Silicon atomic radius is 0.118 nanometers and the electronegativity is 1.8. Phosphorus atomic radius is 0.110 nanometers. Phosphorus electronegativity is 2.1. Sulfur atomic radius is 0.104 nanometers. The electronegativity is 2.5. Sodium, magnesium, aluminium, silicon, phosphorus, and sulfur physical state is solid. Chlorine atomic radius is 0.100 nanometers. The electronegatividity is 3.0. Argon atomic radius is 0.094. These two elements, chlorine and argon, exist in gas states. The increase the number of protons across period 3 will increase the charge in atom's nucleus. Electronegatividity of elements will increase because the nuclear attraction force towards the electrons increase. Physical state of period 3 elements will change from solid to gas from left to right. Sodium, magnesium, and aluminum are metal elements. Silicon is a semi-metal element, while phosphorus, sulfur, chlorine, and argon are non-metal elements. The last groups of elements that I will be sharing about today is transitions elements. Some examples of transitions elements or metals are chromium, manganese, iron, copper, zinc, and nickel. These elements' properties are solids with shiny surfaces, very hard compared to metals in groups 1 and 2, have higher densities, and have high melting points and boiling points. Transition elements function as a catalyst to increase the rate of reaction without undergoing chemical change at the end of the reaction. Transition elements form colored ions or compounds. For example, copper to iron or Cu2 plus color is blue. Manganese to iron is pink. Transition elements have more than one oxidation number. For example, iron have two oxidation number, that is +2 and +3. The compound example is iron 3 sulfate FeSO4 and iron 3 chloride FeCl3. Transition elements can form complex ion like hexacyanoferrate to iron. The formula FeCN6 4-. Transition elements uses in our life. Iron is used in Haber process to produce ammonia in H3. Platinum is used in the Oswald process to produce nitric acid HNO3. Vanadium pentoxide is used in the contact process to produce sulfuric acid H2SO4. Nickel or platinum is used in hydrogenation process on vegetable oils to produce margarine. And that's it for now. And once again, I would like to say that my name is Nur Atira Natasha binti Abdul Razak from class A4AS120120. Thank you for watching and listening to my video. Bye bye!